So today's lesson is about similarity and scale. And these are the final two concepts in the lesson, in the unit before the summative. And it's really just circles, working with circles. And then these two concepts. Similarity is new, but also it's a really easy concept because you guys already know the word similar. And scale is just an extension of ratios and percents that we've already done this year. So easy peasy. But like always, we have our warm-up. So go ahead and solve these and then watch the video to figure out if you did it correctly or not. Nice, easy review for you guys today, and you just did it on the Badger test, for being honest. So, we have 12 squared plus 4 times 23 minus 11 times negative 2. Remember, order of operations. Exponents first. So we have 12 squared, 144, plus 4 times 23 is 92. And negative 11 times negative 2 is positive 22. So let's add these up, and I have 144 plus 114. And if I keep adding, I get 8, 5, 2, a grand total of 258. Double check my mental math for me. Next, we have to solve our inequality. Solving inequality is very similar to solving equations, except rather than equal sign, we have our lovely inequality sign. So we have 5x plus 14 is greater than or equal to 54, rather than simply equal to. Still, like always, we can draw our line. Let's minus this 14 first. And I'm left with 5x is greater than or equal to a grand total of 40. Divide by 5 on both sides to solve for our x, and we get x is greater than or equal to 8. If we would plug this back in, it would make a true statement. And remember, not only is x 8, but x can be any number bigger than 8 because it's greater than or equal to. So we could choose 1084. It doesn't matter. So, first today we're going to talk about similarity. To kind of get you started on the right track, first think of what does it mean for things to be similar. This key word similar and similarity. Similar. Easy, right? We know similar things are alike. We could maybe say they're kind of the same, but not exactly. And that's essentially all similar items are, is they're alike, but not exactly the same, but really close to being the same. So, similar shapes, and we're focusing specifically on similar triangles. If they're really close to being the same, we have this big triangle and this big triangle. They're really, really close to being the same. And so, one thing they do have exactly the same is our angles. Their angles are equal. They have equal angles in similar triangles. However, when we're looking at the sides, do these sides look equal? Not quite, because they're only similar. So they're kind of alike, or mostly alike, but they're not exactly alike. But remember earlier I said ratios and percents I mentioned? And so, even though they have equal angles, but they're only similar triangles. So rather than having equal sides, they actually have proportional. Proportional sides. So if this is a side of 1, and this is a side of 2, and the rest of this triangle is a 3 and 2, 1 times 2 is 2. So 2 times 2 would be 4 on this side, and 3 times 2 would give us 6 on this side. Notice our sides are proportional. They're all a proportion. If we have triangle A sides over triangle B sides, we have 2 to 1. 4 to 2 is a ratio of 2 to 1. Sides are always going to be proportional. Sides can have an equal proportionality. They could be a 1 to 1 proportion, but that's not common. In similar triangles, sides are simply proportional, while angles are always equal. So now that we've learned about similar triangles, are these triangles similar? Well, remember, what did we say about similar triangles? Similar triangles have equal angles. So what I like to do, before I even compare my triangle, is get them facing the same way. This one, right here, is not facing the same way as our first one. So I'm going to redraw this baby. Big flat side here, biggest obtuse angle, connecting edge. Big flat side is actually our 9 inches. We have 9 on the bottom, we have 9 on the connecting edge, and 7.5 on our obtuse. So now notice our angles are aligned. When angles are aligned, it makes comparing a lot easier. So I would suggest redrawing. You're going to have to do this in your 10 marks. Because if they're not correlated, you can't compare sides. I can't compare this side right here with this side because they're not the equal same sides until, or actually in this case they are. Sorry, bad example. I can't compare my 9 inches with this side because they're not the same side. They're not between the same angles. So I like to redraw first. And now let's see if they're proportional. So on my connecting side that I called it, I have 9 inches on the big one and I have 9 inches on the small one. So I have a 9 over 9 or a 9 to 9, which is really a 1-to-1 proportion. Let's see, do I have a 1-to-1 proportion with my other sides though? Let's look at the bottom. I have 9 and 6. So I have to do a small one on top. So this is my small triangle, this is my large one. So I have to keep it small over large. Small triangle has a side length of 6, large has a 9. If I reduce, I get 2/3 small to large. Are these ratios the same? No. So are my sides proportional? Not at all. So are they similar? If we're going to go that far? No. And it's because my sides are not proportional. Even though my angles are equal, my sides are not proportional. And so these triangles are not similar. Not even close. And that's how you determine. But remember, we have to redraw them so that they're facing the same direction because it makes your life a heck of a lot easier. Finally, scale. And when we scale things, a lot of things change. So we start with this red drawing of a 2 by 6 centimeter rectangle. And we're going to reproduce the drawing by a factor of 2 and make this larger purple rectangle down here. So when it says reproduce it by a factor of 2, that means we want to enlarge each side by 2. So 6 times 2 is 12 for the long side. 2 times 2 is 4 for the short side. Now, if we pause right here, would these be proportional? Let's check. Small one over large rectangle. So 6 over 12 is a half. 2 over 4 is a half. Yeah, so notice because we increase them by the same factor, a common factor to both sides, they are actually proportional sides, so we have similar rectangles. So we can recognize similarity, but that's not what it's asking. It asks us to relabel our measurements. So we did that by the factor of 2. But now it asks us what actually happened when we did this. So when we increased it by a factor of 2, what happened to our side lengths? Well, what did we do? We multiplied by 2 to each side. So what happened to the side lengths? They doubled. Or they increased by a factor of 2. They just went up by 2. Easy, right? But now let's think. What happens to the perimeter? Is it still going to double? Or is it going to do more? I think the easiest way to figure out is to compare. So if we look at the small one, the perimeter, we know the side is 6, 2, just add them up. 6 plus 2 plus 6 plus 2, so it's 12, 13, 14, 15, 16. We get a total of 16. What about the large one? We have 12 plus 4 plus the other side's 12 and 4. 12 and 12 is 24 and 8. we get 32 centimeters. So, what happened to our perimeters? We all know how to find perimeter, but what happened? So when we reproduce the drawing by a factor of 2, notice our perimeter doubled. It's all it did. It's just like our side lengths. Perimeter and side lengths, all they do is double. So now it's asking, what about area? Is it going to be the same? If you're looking at what we have so far, we're going to want to say it doubles, but let's figure out if that's true or not. So let's first find the area of the small triangle. Area of a rectangle, remember, is length times width. So we're going to take 6 times 2. Easy. We get an area of 12 square centimeters. Now what about the area of the large one? 12 times 4. That's 48 centimeters squared. So now we're comparing 12 and 48. Did our area only double? If it went up by a factor of 2, the side lengths doubled, the perimeter doubled, but now notice what happened to the area. Area quadrupled. It increased by a factor of 4. A factor of 4. Why do you think it's 4? What relationship is there between 2 and 4? I hope you figured it out. It's 2 squared. And notice, area, the label is squared. Here, our factor is also squared. So, but over here, centimeters, not squared at all. Factor of 2 multiplied by 2, or doubled. Here, centimeters, factor of 2, doubled. Here, centimeters squared, it's our factor of 2, but then we had to square it to match the label. And so we got a factor of 4. And so that's just kind of a thing to get you thinking on. If you're not confident, you can always just use actually figuring it out. But something to think about. What happens if we would have increased it by a factor of 3? Would our area still have quadrupled, or would it have done something else? Things to ponder. So, the rest of the assignment is 10 marks. Have fun.